Okay, let's get started. Great. Today I want to talk about the way in which we are able to determine 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 how old a piece of land or some other geographic feature is dating techniques. I'm going to talk about a per, particular particular dating technique. Why? Good dating is a key to good analysis. In other words, if you want to know how a land formation was formed, the first thing you probably want to know is how old it is. It's fundamental. Take the Grand Canyon, for instance. Now, we geologists thought we had a pretty good idea of how the Grand Canyon in the southwestern United States was formed. We knew that it was formed from sandstone that solidified somewhere between 150 or 300 years ago. Before it solidified, it was just regular sand. Essentially, it was a part of a vast desert. And until just recently, most of us thought the sand had come from an ancient mountain range very close by that flattened out over time. Now that's been the conventional wisdom among geologists for quite some time. Over time, that's been the conventional wisdom among the geologists for quite some time. But now we've learned something different and quite surprising using a technique called uranium lead dating. I should say that uranium lead dating has been around for quite a while, but there have been some recent refinements. There have been some recent refinements. Uh, uh, have been quite a while, but there have been some recent refinements. I will get into this in a minute. Anyway, uranium lead dating has produced some surprises to geologists. Discovered that about half of the sand from the Grand Canyon was actually once part of the Appalachian Mountains. That's really eye-opening news since the Appalachian Mountain Range is, of course, thousands of kilometers to the east of the Grand Canyon. Sounds pretty unbelievable, right? Kilometers. Kilometer to the east of the Grand Canyon. Sounds pretty unbelievable. kilometer. Right? Of course, the obvious question is how did the sound end up so far west? And so far west, the theory is that huge rivers and wind carried the sound of west where it mixed in with the sound that was already there. Well, this was a pretty revolutionary finding. And it was basically because of uranium red dating. Why? Well, as everyone in this class should know, we usually look at the grain type within sandstone, meaning the actual particles in the sandstone, to determine where it came from. You can do other things too, uh, like look at the wind or water, water, water that rolls the grains to their location and figure out which way it was flowing. But that's only useful up to a point, and that's not what these two geologists did. Uranium dating allowed, allowed them to go about it in an entirely different way. What they did, what they did was they looked at the grain of zircon in the sandstone. Zircon is a material that contains radioactive uranium, which makes it very useful for dating purposes. Zircon starts off as molten magma, and that hot lava from volcanoes. This magma then crystallizes, and when zircon crystallizes, the uranium inside it begins to change into lead. So if you measure the amount of lead in the zircon grain, you can figure out when the grain was formed. After that, you can determine the age of zircon from different mountain ranges. Once you do that, you can compare the age of zircon in the sandstone in your sample to the age of the zircon in the mountains. If the age of zircon matches the age of one of the mountain ranges, then it means the sandstone actually used to be a part of that particular mountain range. Is everybody with me on that? Good. So, in this case, uranium red dating was used to establish that half of the sandstone in the samples was formed at the same time. The, the granite in the Appalachian Mountain was formed. So, because of this new way of doing uranium red dating, we've been able to determine that one of our major assumptions about the Grand Canyon was wrong. Like I said before, uranium red dating has been with us for a while, but until recently, in order to do it, you really had to study many individual grains, and It took a long time before you got results. It just wasn't very efficient, and it wasn't very accurate. But the technical advances have cut down on the number of grinds you have to study, so you get your results faster. So I predict that uranium-red dating is going to become an increasingly popular dating method. There are a few pretty exciting possibilities for uranium-red dating. Here is one that comes into mind. The theory that the Earth is a continent were once joined together and only split apart relatively recently. Well, with uranium-red dating, we could prove that more conclusively if they show evidence of once having been joined. That could really tell us a lot about the early history of the planet's geology.